يعطيكم العافية. Good evening. Today we will discuss the first exam material for the 9th grade mathematics. Let's start with the first lesson. It's about the Cartesian coordinate system. And here we can see the Cartesian coordinate system. It's a two-dimensional surface on which a coordinate system has been set up, invented by René Descartes, also called Cartesian plane and graph or grid, coordinate grid. The coordinates, the number and the ordinate pair that locate a point in the coordinate plane. So if I want to put a point, I should order a pair, the pair built of y and x and y. In order they have to be x, and then we can see the y. Yes. So that's the representation of a point in a coordinate grid. The x-axis is a horizontal number line on a coordinate grid. The y-axis is a vertical number line on a coordinate grid. So this is a vertical, this is a horizontal, and we can have the Cartesian coordinate. Then we will split the coordinates into, here, if I draw it here, into 4 quadrants. 1, 2, 3, and 4. So the 4 parts made by x-axis or x points and y points, or x-axis and y-axis. The origin here is 0, 0. That means that x at the origin equals 0 and y at the origin equals 0. The intersection of x and y axis, it's the origin for the quadrants or the Cartesian coordinate. Let's move to the next slide. You can see here the coordinate 1 or coordinate 2, coordinate 3, and coordinate 4. You can see here that we have plus plus, it's the first quadrant. The second quadrant, it's minus plus, minus x. Y is positive, so on. And here the third quadrant, it's minus, minus, so x minus and y will be minus. If we continue, we can see here that at the fourth quadrant, we can see that x is positive and y is negative. I can memorize that using just the positive and the negative thing. I can see that here we have positive, negative, positive, negative. If I give you a point here, it will be positive, positive, and if I give you a point here, it will be negative, positive. And we should remember that the horizontal line or the horizontal axis and the vertical axis, this is the y, this is the x, and so on. So I don't have to remember, I just have to understand. So this is a point here, minus, minus. This is point here, this is positive, minus. So x is positive, y is minus. So let's continue. If I told you this is point 1, 2, so I have to jump 1 to the upside, 2, 1 to the right side, and 2 to the upside. So this is the point that I need. If I told you I need 2 minus 3, so I have to move 2 to the right, and minus 3 to the downside. So this is the point. And we can see here that I'm just jumping between the lines until get the point. If I have 2, I have to move 2, maybe right, maybe left, but I have the positive, so I have to move right. Minus 3, I have to downward 3 points or upwards 3 points, but here I have negative, so it's downward. And so on for the other points. Here we can see, before that, we have to know the linear function. So the linear function is a function made of mx plus y. So if I see it here, can view it, we can see here that it's made of mx plus b. M is the slope of the equation or the linear function, is the slope. B is the crossing the y-axis point. and x is the variable, y is the main of the equation. Here we can see, as I told you, that m is the slope, p is the y-axis crossing, and x the variable, and y is also, we can name it as f of x. So they are independent and dependent variables respectively. M not equal to 0. We can see here that maybe we can change f of x into y. So it's just names or representation letters. Here we can see the difference between the linear equation and nonlinear equation. Here we can see that this equation 8x minus 5, it's into the formula mx plus b, so it's a linear function. Minus x over 3 plus 2, m here is minus 1 over 3, b here is 2, and this is a linear function. Y equal x, this is a linear function also, m equal 1, and b equal 0. So I'm crossing the y-axis at 0. The fourth one is not linear function because we have the x at the denominator, not on the numerator. So if the x or the variable is not in the denominator, so it's not a linear function. If we see the other function, it's x squared minus 3, so it's not a linear function because the degree of the equation is not 1. So it has to be 1, it has to be the denominator, it has to follow the formula of the linear function, which is mx plus b. Here we can see the table that we have y and x, or f of x and y. If we just put instead of x, minus 2, we can get minus 3. If we put minus 1, we can get minus 1. How I can get it like this? 2 multiplied minus 1, minus 2 plus 1, so it's minus 1. And so on. If I put it 0, it's direct 1 because I'm removing the x of x variable and its coefficient, so it's direct 1. And instead of x put 1, can get 3. Instead of x put 2, I can get 5, and so on. This is the order paired. I can represent that with a linear function. It's linear function represented on the Cartesian coordinate. I'm using here the Desmos representation or Desmos web page, so it's depends on you. Here we can see that when we are changing the linear function, we are changing y constant. So if I change x, I'm changing x by constant, and changing y, I will change it also by constant number. So it's a linear connection between all of them. This is a pop quiz. You can see the answer here. It's minus 1 and 8. If we just put here minus 1 instead of x, I can get here minus 5 plus 4 multiplied 8. It's 32. So 32 minus 5, it's 27. That's right. So the B is the right answer. Here we can move now to the last of all of the lessons or the material. We can see here that we have the graph of a linear equation. We can use 3 types. One of them is using table, t-table. We took it to the linear function, using the slope-intercept form, or using the xy intercept. I can explain that by the standard form. We can use this as standard form, or we can use this as slope-intercept standard form that we took in the linear function. Here we can see that ax plus by equals c. It's also similar to this equation. Just by putting y as the main of the equation, we can have like this. We can have minus a over b x plus, I'll put the plus here, c over b. So I can have the same thing. It's minus a over b. It's similar to m. If I put a as minus 2 and put b as 1, I will have what? I will have 2 and m equal 2. So it's just constant and coefficients and can change them until get the same meaning. But I will see which easier to us or which easy to us to draw the function or the linear function. So if I have this formula, I'm having minus 1 over 3x plus 2. This is a formula of a linear equation. And I want to draw it, I can use it by like this or like this, by using m equal minus 1 over 3, using b equal 2. From the first thing, we should say that at the linear function, we say that this b, it's represent to us that we have the start or the crossing y. So now I know the crossing y point, it's 2. So this is 2 is the crossing y point. I will change the color so it will be more identify. So if I change it and see what the effect of the slope or m, I can see that here it's minus 1 over 3. So first of all, the numerator tell me if I have to go up or down. The denominator here tell me if I have to go right or left. And what's change it? The change it's the sign. So if I have minus 1, so I can change it like this. I can go up 1 and go 3 points for the left. How did I know that? I just used the sign for one moment or one time. First thing I did that I'm using the sign like this. I'm using 1 to go upward, using minus 3 to go left 3 points, to go to the left for 3 points. If I'm using the same thing, I will use 1 or minus 1 to go down and using 3 to go 3 points. So I will get this point and I can continue the line. So the same. If I want to another point, should start from this point now, go 1, 3, and so on, and make a line between them. This is the linear function. So that's it for this way and for this formula. It's easy to use this graphing method, graphing with a slope intercept. Now, if I want to use another formula, I have another formula, I have minus 2x, 3y equal 12. The best thing is to using the standard formula or not using the standard formula, using the intercept points between x and y. How? We should just know the 0 point for the x-axis and y-axis, where I'm crossing the y-axis and where I'm crossing the x-axis. If I want to know where I'm crossing the y-axis, what should I do? Just put x0 so I can see where I'm crossing the y-axis. Here, I can see that if I put x0, I'm removing this side. It's just 3y equal 12 over 3 over 3. So it's 4. 4. So it's here. So, Mr. Adham, if I want to know where I'm crossing the x-axis, what should I do? Just I have to see where I'm getting y equals 0. And then I can know where I'm crossing the x-axis. So this is the y equals 0. So removing y, dividing by minus 2, dividing by minus 2, I'm getting minus 6. So this is the other point. I just have to make a line between 2 points and after that I can get the linear function. So if I want to calculate or if I want to check that I'm right or not, try to go put a number. Try to put y equal 1. Let's see the answer here. It will get here. Let's see the answer. Y equal 1, so it's 3 minus 2x equal 12. 12 minus 3, it's equal 9. 9 divided by minus 2, it's equal minus 4.5. So x equal minus 4.5, so that's right. So I'm using the best method for this idea. So which method is easiest to use this to grab this equation? The easiest thing is using x and y intercepts. Why? Because it's on the on the formula of the y and x intercepts. Which of the graph represent y equal x plus 2? The fourth one, how did I know that? 2 is equal to cosine y-axis, and x, if I put y as 0, I can see that x equal minus 2, so line between them, and that's right. الله أكبر الله أكبر، يعطيكم العافية، إن شاء الله امتحان موفق، وشكرا لكم جميعا.